Good morning, everybody. It is Tuesday morning. It's election day. Oh my gosh, let's get through this day. Hope and pray for a safe America. Okay, anyway, 11:3. So, one of the things I want to do first, real quickly, is just review square roots. A couple examples, and you can just watch. If I had, for instance, let's go 3 times the square root of maybe an 18x to the 5th. What we've learned is we need multiples of 18 that have a perfect square, like 9 and 2. What we also know is we need to get this to an even number, so we need the square root of x to the 4th and square root of x. If we take one away, it makes an even number. And then this, just to review, square root of 9 is 3. So this whole number with this 3. Square root of 2 we're going to leave alone because it's an ugly number. It's an irrational number. Half of the exponent makes an x squared. Now what's left is this square root of 2 and the square root of x. Put those together and finally we'd have a 9x squared square root of 2. Okay? X. Yesterday we talked about rationalizing roots. If I had maybe a 5 over the square root of 3, we learned that you fix the problem with the problem. So I'm going to multiply top and bottom by, can't have a square root. We fix the problem with the problem, square root of 3 over the square root of 3. So what we get is on the bottom, the denominator, we get the square root of 9. That's why we do this. And the square root of 9 is 3, so we no longer have a square root in the bottom. But on top, it changes the numerator to just 5 square roots of 3. Sure, we still have a square root, but it's in the numerator, not the denominator, okay? And then finally, we looked at the hard ones. We looked at something like this. Let's go 3 over 2 minus the square root of 5. And we learned that you can't just multiply by square root of 5. You got to multiply by the conjugate, fancy word conjugate, 2 plus the square root of 5, both the top and the bottom. And what happens is, in the denominator, that's the bottom, we get a 4. These two will cancel because you get positive 2 square roots of 5 and a minus 2 square roots of 5. They will cancel, and then minus a square root of 25. So what our goal is to get rid of all the square roots on the bottom. Gone, gone, and the square root of 25 is 5. Gone. Pretty cool, huh? Now on the top, the numerator, we still have a 6 plus 3 square roots of 5. Okay, but what about the denominator? Well, that's a 4 minus a 5 is a negative 1. No more square roots. But on the top, sure enough, there's a 6 plus a 3 square roots of 5. Okay, so we're going to keep practicing these. We're going to keep working on these. But today's lesson is different. You see, this whole chapter has to do with x squareds. We're talking about x squared equations, which are quadratics. It's a fancy word. We're talking about quadratics. So today we're going to be finding zeros from x squared equations. We're going to call them quadratics. We're going to call them quadratics. Okay. Today's date, 11/3, election day. Whew, big day. So, on example 1, what we want to do is take a look at finding the zeros. Well, the zeros are to solve for it. Now, I know there has to be 2 answers. Has to be 2 answers. Must be 2 answers. So to get 2 answers, let's get 2 mini equations. But to get mini equations, let's factor. So let's factor. Well, we haven't done this for a while, but I'm going to do what, in this example, what I call common factoring. Well, what's that mean? They have a common multiple of 3, common factoring, they have a common multiple of 3, and they both have a common x. So take out what they have in common. Common factoring, take out the common factors, 3, multiple of 3, and an x. What's left over, if I take out the 3x, is an x plus 2, and you can check your work by multiplying through. 3x times x, 3x squared, 3x times 2 is a 6x. Now, we have our mini equations. So we want it for 2 answers. We have 2 mini equations, one of which is 3x equals 0. That's what we want to do, is get our mini equations. We've done this before. And our x plus 2 equals 0. Okay, if we solve, easy, divide by 3, x equals 0, plus minus 2 minus 2, right? X equals negative 2. These are both zeros. If you plug them into the equation, you get 0. Check it out. I'll just show you one of them. Let's take the negative 2. If I go 3 times a negative 2 squared plus 6 times the negative 2. Guess what? It's going to be 0. Yes, 0, because that's what it is. Okay, example 2. Well, we're going to factor. Yes, we're going to factor. Let me put a 1 here. But this is a trinomial factoring, so I'm going to go parentheses, 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 right? And then what I'm going to do is go x and x, multiples of 12. How about a 4 and a 3? How about a negative 4 and a positive 3 equals 0, okay? And then from here, there's my mini equations. An x minus 4 equals 0 and an x plus 3 equals 0, right? And I solve. Plus 4, there's 1, 0, minus 3, there's the other 0, okay? And again, if you plug both these in, believe it or not, you'll get an answer of 0. Oh, come on, what the heck? Come on, I'll show you. Plug in the 4. 4 squared minus 4 minus 12. Boom, 0. What do you know? That's kind of what I expected. So the zeros are also x-intercepts. So if you were to graph this thing, 1, 2, 3, 1, 2, 3, 4, it would look something like this, but it goes through at 4 and negative 3. Those are zeros. Okay, example 3, we're going to factor. Okay, boom, 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 boom. I'm going to get a 2x and an x, right? Multiples of 5. That's going to be 2x times x makes 2x squared. Multiples of 5. How do a 5 and a 1? We have to be careful because we're going to check off with our double smiley. Got to be careful. I'm going to put the 5 here and the 1 here. And I'll show you why. Remember the double smiley? Let's check it out. That's a 1x, 10x, 1x, 10x makes 11x. Make both positive, positive equals 0. Okay, now what we have at this point is two mini equations. So we're going to have a 2x plus 1 equals 0. Right, again, mini equations, two answers. How many answers? Two answers. And an x plus 5 equals 0. Okay, then I'm going to keep solving. Minus 1, minus 1. I got a 2x equals negative 1, right? Keep solving. Divide by 2, and I got x equals negative 1/2. There's one of my zeros. And again, if you plug that in, yes, it will give you an answer of 0. It really will. Minus 5, x equals negative 5. So there's my two zeros. Okay. All right. Now let me keep going. Okay. So if we graph this, okay, so graph it on a calculator. So let's see. You guys probably are going to have to use Desmos. Get your phone out. I'm going to show you on my phone. All right, so if I go to my Desmos, and you guys should have, if you don't have Desmos, you should get Desmos. If you don't have Desmos, you need Desmos. So I'm going to go simply y equals, and I'm going to go x squared minus 2x. If you don't have Desmos, please get Desmos. Minus 5. There it is. Now, if I want the zeros, they're there. There and there. So tap. Okay, about 3.4. I'm going to round up 3.45. So 1 zeros. So I graph it. So a rough sketch like that. So one of my zeros is x equals a 3.45. I just got it from my calculator. If you do not have Desmos, you need Desmos. You can get it on a calculator. You can get it on your phone. You can get it on a computer. The other zero, here it is a negative 1.45. Easy, huh? Just put it on a calculator, okay? Same thing on 5. You're just going to graph it. So if I graph this, you'll see the same thing happen, but I don't really need to do it because it's the exact same thing. So the moral of the story for today's assignment is, if you don't have Desmos on your phone, please get it. It's also on a computer. You can get it on your computer. Just look up Desmos calculator. Desmos. Here, I'll write it down. Desmos. If you don't have Desmos calculator on your phone, look it up on your computer. It's free, doesn't cost anything, and it will do all of this work for you. Because if you're looking for the zeros, you're looking for those values there and there. That's the zeros, because that's the height of the graph is 0. Okay, that's all I have. Have a great day. Hopefully the day will turn out just great for you, okay?